Hi, hello everyone. So we've had a look at a couple of things now. We've had a look at algorithms and the different types of algorithms, algorithmic thinking, decomposition, all that. We've had a look at the Turing and machine and how that kind of builds that all into the conceptualization of doing a computer program using a CPU, all that. So we're going to have a look at a very specialized area now, super duper specialized area, and that's the area of heuristics. Okay. So I suppose first of all I'm going to explain in general terms what heuristics is, then specifically how it relates to computer science in terms of a couple of examples, and then hopefully by the end of it you'll have an idea of how it's used, what it means, and why we should be careful of it. Okay. So heuristics, they're little rules. They're little rules, cheats, for want of a better word, that help you do things quickly. They're not perfect. We'll talk about that in a second. They're definitely not perfect. They're fast, very, very fast. And I suppose one phrase I would and they're kind of, this would probably easiest way to kind of sum them up. They don't let perfection be the enemy of good. That's a nice way of putting it. There's probably other phrases that kind of like that, but they don't let perfection be the enemy of just good enough. Okay, so first of all, I suppose I'm going to talk to you just. We use algorithms all the times, okay? And we know what an algorithm is, okay? At this stage, we know what it is, okay? A list of steps, which if you put in an exact amount of steps with an input and do exactly what is said, it will transform into a desired output. So in other words, here's your algorithm. If you put in an input, data, whatever it is, you get out an output. That's what they do, okay? That's their raison d'etre of algorithms, okay? So take, for example, the sorting algorithms that we would have used, okay? The binary one, the bubble sort, any of those, okay? And they convert a list of random integers into a list of integers in a particular order, okay? Just for example. Now, there are other algorithms that could be used to list those integers, and you get a sorted list. There's lots of different ways you could have done it, but we use those particular algorithms because we know they're efficient and they do the job, okay? However, heuristic algorithms don't follow that same perfective step-by-step process. They make guesses, they make jumps, leaps of faith, they make assumptions. And most of the time, those heuristic algorithms are right. So what you do is you do a trade-off. Okay? And you trade off reliability. In other words, the algorithm is always right, but you trade off that reliability, and instead you gain speed. Okay, and that's the key to heuristics. It's the trade-off between reliability of a perfect algorithm and speed. Now, the most common place you'll see heuristic algorithms is facial recognition. Okay, I'm going to use this example because it's one that, so A heuristic algorithm won't look at absolutely every pixel in a facial picture. It just won't. It'll take groupings of pictures, and it'll make assumptions that the rest of the pixels around there should follow a set amount of, you know, criteria in order to build up the picture of the person and identify it as yes, it's him, or no, it's not him. Okay, so it's not like when you take your thumbprint and you roll it on the page and every part of the thumbprint has to match exactly. No, this instead looks for key markers in a thumbprint. Now, I'm going to try. Do not try this at home. Okay. Okay, so rather than look, and you've seen this in the movies, rather than look at absolutely every line, what it will do is it'll look for key markers. And it will, you often see the magic lines appear then on the computer program on the telly. 99% match, it's your guy, type of thing. Okay, so it just looks for that match. That's your heuristics working. Okay, it could take days for it to look at every swirl, every curl, every possible line, and also check all the widths between each line. No, it just looks for key markers. It does its assumptions, and it bypasses all that time. So you lose a bit of reliability, but you gain the speed and you catch the bad guy. Okay, that's the idea of the heuristics algorithm. I suppose if I was to put it down into and explain it like I'm a 5-year-old type of, imagine you're heading home from the shops, okay, and let's say it takes about 10 minutes to walk. Now there's probably a lot of different ways you walk home, okay. You could so I'm just trying to think. No, let's do the school to down to the village, 10-minute walk. Okay, you go right down the hill. Okay, it's a bit boring. You go right down the hill past the girls' schools, down the hill past the can't remember the petrol station, and down the yard to the village. That's one way of doing it. Okay, but you could have come up the other way, the long way. Okay, you could have come up through the park. There's multiple ways you could have got back to the school or got down to the village, but you took that way. So you can decide the best way to walk each time, and you can make a note. Over time, you'll realize that some ways are better than others. Okay, some ways there might be distractions on one way. In wet weather, one way is a better way, another way is a better way. Okay, you might meet a scary dog one of the days. Okay, your brain sorts these things out. It remembers all these different things, these different rules about which one is the better and which one is the worst way, given a certain amount of criteria. Now, you don't consciously do this. Your brain makes these decisions subconsciously, but what your brain is actually doing is heuristics.